Math is hard, not because we are not intelligent to learn, but because we were taught all these formulas and theorems without really knowing how to use them. An analogy is when we're given all these ingredients to make a cake, but never the recipe of how to put these ingredients together.
This is why learning math for data science, everything starts and ends with failure. At least this is what I felt.
I was kind of trapped in this cycle, and one day I just came to the conclusion that I'm not a math person. Until one day I realized the one thing, and that is having a genius level IQ and creating mathematical entities versus being able to understand and use math as a tool to solve problems are completely different things. The former is a gift from the universe, whereas the latter is a skill set. Now, if you want to work in academia or an R&D role, that's a whole different animal. But for most of us who work or will be working in the industry, the ultimate goal of learning math and data science in general is to solve business problems. So if that's the case, then why don't we adopt a top-down approach? And that is, we start with an analytics problem to solve, and then we learn all the math needed to bring the solutions to life. Just like we have our goal of making a cake, and then we collect all the ingredients to do it. Now, the good news is that to break into a data science career, we really don't need a ton of math. So next up, I will show you how this top-down approach, or I call it building to learn approach, works in order to maximize your learning outcome. We're gonna do this at a super high level without really getting into the weeds of math calculations. My hope is that this example will give you an intuition of how these 4 pillars of math play out when you do this project-oriented approach on your own. Then I'm going to share my top 3 tips to learn math faster, and more importantly, to remember what you've learned for longer. And actually, one tip helped me get my first data scientist job. Let's say you're a consultant for a company called So Yummy LLC, which is a pet food manufacturer, and your project is to predict the sales of one of their dog food lines. And they have been collecting data about price, ingredients, and whether or not the product is organic. And these are the predictors available for you to work with. And of course, you also have sales of the previous years as the dependent variable. First thing first, we need to understand the data set, which a fancier technical term is exploratory data analysis, or EDA. So basically, EDA serves as the initial investigation into our data, and the main purpose is to identify obvious errors, if there's any, and also discover patterns. To achieve this, we need basic statistical knowledge, or descriptive statistics to be specific. And usually there are 3 steps going into the EDA process. So first, we focus on one variable at a time. For continuous variables like the dog food price, we create histograms and identify outliers. And then for categorical variables like organic versus non-organic, we look at their count and frequency. So all of these rely on the knowledge about variable distributions. Moving on from the univariate EDA, we also check the relationships or correlations between 2 or more variables. Usually, EDA is all about exploring and summarizing numbers, so to make a visual impact, we also supplement EDA with various data visualization techniques. For example, instead of showing this numeric matrix, we can use a heat map to represent correlations among different variables. Now, as we can see, all the math we need for basic EDA is statistics, particularly univariate and multivariate distributions and correlations. After we've gained some insights into the data, next up, we need to represent our data in a way that computers can work with. And this brings us to the concept of vectors and matrices, which falls into the realm of linear algebra. Here, the variable price is represented by this blue vector, variance ingredients is represented by this green vector, and organic versus non-organic coding is a red vector. And then if we combine these 3 vectors together, we get a matrix. That's just as simple as that, right? With this, we're ready to build a linear regression model using this matrix to make our predictions on total sales. Since there are multiple variables in our data, so we're going to build a multivariate linear regression model. And this is performed using matrix operations or matrix multiplication under the hood. The predictors matrix we just looked at is called design matrix, and a regression model is to find a coefficient matrix that links the design matrix and our dependent variable total sales. Now, how do we find this coefficient matrix, you may ask? Recall that our goal is to get the predictions as accurate as we can, and that is to reduce the prediction error of future sales to its reasonable minimum. So to achieve this, we use the gradient descent optimization, and this is where calculus comes into play, especially derivatives and integral. Once we find this coefficient vector, we just plug it into this formula. We will then come up with our final sales predictions. This concludes our project with the So Yummy LLC, and we've covered enough math fundamentals for you to get started. Then later, as you work on more problems, you will learn more advanced topics, but those won't be intimidating because you already have all the fundamentals laid out, and more importantly, you already know how to use them. You may have already noticed that I used a lot of visuals and animations through this video, and this is my first tip to make your math learning process more productive and also to help you retain your understanding longer. We all know that math is abstract, but animations and visualizations can help explain some complex concepts. Next tip, which is probably the most effective one, is to work with the smallest toy data and calculate it out manually. So to give you one example, when I first learned neural networks, I developed a model on a piece of paper. Well, actually no, 2 pieces of paper by hand. It was a tiny net of 2 layers with just 2 neurons in each. But going through the forward propagation, derivatives, and backward propagation really demystified how a neural net is configured and applied. And then my last tip for you is try to come up with analogies to explain the complex math or algorithms in plain English. And so here is my own experience. I got my first data science job because I explained a tree model in layman's terms. So in my interview, the hiring manager asked me to explain random forest to his 5-year-old daughter. Here's my response. Let's say you are interested in the Disney movie Beauty and the Beast, but you don't know if you're gonna like it or not. So you ask your best friend Sally whether she thinks you will like it. Sally knows that you like Disney princess movies and that you like Emma Watson, and she also knows other characteristics about you. So these pieces of information are the training data for her to come up with a yes or no answer. So here, Sally is a decision tree. Only Sally's opinion isn't sufficient enough for you to decide, right? Then you ask a bunch of other friends the same question, like Tom, Billy, and Amy, etc., and they each know different things about you, which is equivalent to say that they have different predictors as to whether or not you will like the movie. And this is another layer of randomness. Now, each of your friends represents a single trait to give you his or her decision, and when combined, they form a forest. And that's the basic concept about random forest. Later, my boss told me it was this answer that stood me out from other candidates. So to me, when a concept is full of math terms, I'd always try to come up with some analogies. This not only reinforces my own memory, but also makes it easier for my non-technical stakeholders to understand. Now you have it, all the basic math knowledge for data science and my tried and tested tips for maximizing your learning outcome. Now, comment down below if you have any ideas or thoughts, and also don't forget to like and subscribe. So see you guys pretty soon in my next video. Bye guys!